So let's move on from there. And the next one in that top 10, if we flick back there, was around broken authentication and session management.
Yep.
Now, keeping in mind that IWASP is technology agnostic and it's kind of broad, we need to sort of make our own interpretation of what that might look like.
Yeah, because I was going to ask, what is broken authentication?
Yeah, well, it's application functions related to authentication and session management are not implemented correctly. So it's a very broad interpretation, but let's have a look at what that might look like. Let's go back to here. So we're logged in at the moment, and I alluded to this just before, but if we go into our resources, cookies, for Sugar Learning, we have an ASP.NET application cookie here.
Yep.
So this is the default cookie name that Identity, ASP.NET Identity 2.0 will set when you log in. Now, in this case, there's a couple of things here that make me happy. So, number one, your value is not something like 7. So, don't laugh, I see this happen.
Really?
So often what will happen is people say, all right, so someone has authenticated to the session. Now, we'll take a step back. So we're working in HTTP or HTTPS. It's all part of HTTP.
Sure. Yep.
Now, HTTP is stateless. Okay, so each one of our requests is effectively an independent request across an independent connection. So we have to implement our own method of knowing that this is the same person coming back to the system on each request and that they are authenticated. So how do we do that? So how do we persist information across requests?
Yeah.
Well, the most common way of doing that is with cookies. So someone will log in and it will set a cookie and it will say, your identity is this. And the next time that person comes and they make a request, it will send that cookie and the server can go, okay, great, I know what your identity is.
Yeah, you're still the same person.
Now, one way you could do that is you could say that your identity is 7 because 7 is the ID of your record in the database.
Yeah.
And again, like we laugh a little bit about this because we know how crazy it is, but I do see this happen a lot. And there's an interesting assumption around trust that's made where the developer says, I'm setting the cookie. This is my application. You're going to give me back the cookie that I've set. But of course we can change cookies.
Yes.
So we can go in and edit this cookie and we can go and just create a brand new request with our own cookie if we want. And we can change 7 to 8. And if we do that, we will get somebody else's record.
Yeah, yeah.
And I do see this happen a lot. Well, when I say a lot, I see it happen far more than what you would think, which is
you
many
would
times.
like to see it not at all, but I'm sure there are. Yeah, that just seems crazy to me. It's just
So in this case, and we won't get into too much detail about the semantics of how ASP.NET does this, but we do have a cryptographically strong token here.
Yep.
You cannot simply enumerate it to something else. You cannot decrypt it outside the server environment and see what is inside it. So we've got a strong piece of data. Unless you have this piece of data, you cannot take over this session.
Yep.
So that then leads us into the discussion about how do we protect this piece of data. Now, it's not a password.
No.
And you know what? I have actually seen cases where the persistence mechanism is persisting the username and the password in a cookie. True story. Anyway.
But that's
Why would you do that?
why would you do that? That doesn't serve any purpose.
Well, it was easy. No, it wasn't me, but I'm sure it was easy. So how do we look after this? Because if you have this, then you can impersonate this identity. So if we took this value just here, that would be enough to go and create another session and be logged in as you. Because this doesn't key it automatically to, say, the browser, it doesn't key it to the IP address, and all of these things would be risky. Because if you, let's say you keyed it to the IP address and you're on a mobile device,
Yes.
and you switch between cell towers or something, and you'd have problems. So this is okay. How do we protect it? There are two things here that make me quite happy. So one of them is we've got a tick in the HTTP column. So if we look over here in HTTP, we've got a tick. So this means the cookie has been flagged as HTTP only. And when the cookie is HTTP only, it means that that cookie cannot actually be read by client script.
Ah, right. Well, yeah, that does seem good.
Now, the reason that is good is because if I can get XSS onto your page, all right, and we'll talk about XSS in just a moment as well, but if I could get XSS in there, it wouldn't actually be able to read that cookie and then potentially send it off to the attacker. So imagine, think about what you can do with JavaScript. You could do like a document.location and then just append document.cookie and send the cookie off, which would be nasty. So you can't do that with this. And the thing is, JavaScript will never need to read this anyway. You really don't want JavaScript reading your authentication token. The other thing here that also makes me happy is you've got a tick on this secure flag here. So what it's saying is that this cookie will only ever be sent over an HTTPS connection.
Yeah. Now, just to slightly sidetrack from this, when should sessions not be HTTPS? Because I know that Google has moved to everything HTTPS. I think Facebook is everything HTTPS as well.
Yeah, so this is a good question, and in fact there's sort of two things here, because you'll notice down a little bit we do have
exactly, that's what I was looking at.
And the session cookie is a little bit different, and we'll come back to the secure issue there too in a moment.
Okay.
But in ASP.NET you have a session cookie which persists any session state, so if you put anything in session state in your app code, then this is the thing that makes sure that you get your session state out on the next request, not someone else's. But you do have a unique cookie for this ASP.NET application cookie, which is essentially for your identity and for your authentication persistence.
Yes.
So they're two different things. Now, usually in neither case, you would actually want it to be accessed by client script. So that's the first thing. So you've done well by flagging that as secure. Now, the value proposition of this, because you might look at this and say, well, the site is served up over HTTPS anyway, right?
Yeah.
But it would only take one HTTP request, and if it wasn't flagged secure, then that cookie would be sent with it.
Yeah.
So it's the right thing doing this, because what might happen sometimes is someone puts in say a link to a page, and it's like it's the FAQs page. It doesn't need to be secure, so we're just going to put in like an absolute scheme reference to HTTP, blah 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 blah, and then the cookie gets sent with the request. And
is this due to the to the perception that HTTPS is slower, or something? Why would you do that?
Why would we do this?
Yes.
So there are several perceptions which are gradually being debunked over time. And to your point, yes, Facebook, Twitter, all these things are pretty much HTTPS only now. In fact, Facebook at a time wasn't HTTPS only. They were serving their login page over HTTP. And there are some very good precedents that have been broken, including Tunisian government, I think it was about 2011.
I did hear about that, yes.
So these guys decided that they would like the Facebook logins of all their people. And there's a funny thing. So when you control the ISPs of the entire country, you can inject whatever you like into HTTP pages. So someone in Tunisia would go, well, give me facebook.com, and if they just did that, it would default to HTTP in the browser. The login page would load, and the government's injected script in there, so that when you submit, it would asynchronously go and make an HTTP request with your credentials, also to facebook.com, so it didn't look suspicious. But because it was HTTP, then they could intercept that request and get the
harvest.
Exactly. So now they've got citizens' credentials, and now Facebook no longer do that. Oh, and Facebook had the Firesheep thing too. Did you ever see Firesheep?
No, what was that?
So this was a plug-in into Firefox, where what you could do is you'd go to an internet cafe, and you would open up the Firesheep plugin, and it would show you all the other people in the cafe who are currently logged into Facebook. Because Facebook were not flagging the cookie as secure, the authentication cookie, and they were sending it round and round and round in the clear. And if you've got a network adapter, which can go into monitor mode, and it can look at the other requests around you on an unencrypted network, it would see these cookies, and it would go, here's John sitting over there, and you go, okay, I want to be John. Bang, now I'm John. And then you could send John a message on his Facebook going, mate,
hi, I'm you.
I'm you. Maybe you don't want to be here at this internet cafe. So Facebook has all that sorted now, which is good news. Now, in terms of your question, is it slower? So there are several complaints that people have had about HTTPS for a long time, which we've now pretty much resolved. So one of them is that it's expensive. You can get an SSL certificate for free from startssl.com. So the price starts at free and it goes up from there.
Right. Is that for businesses as well?
I believe that is meant to be not for profit, but I'm pretty sure that paid certificates start at something like $70 or something
insignificant,
just about
really.
nothing. It's like, I always relate it back to my coffee. Like, it's way, way, way less than what I spend on coffee.
Well, you're a geek, we spend a lot of coffee.
Well, okay, maybe I have a coffee problem. That's a different discussion. But it's insignificant amounts of money.
Exactly.
In terms of speed, so one of the things a lot of people are worried about, as I said, you're encrypting and decrypting. It's going to increase my CPU cycles, which is then going to have an impact on my cost because I've got to have more CPUs and all this sort of thing. So when Google went pretty much SSL only on Gmail, their stats showed about a 1% increase in CPU load.
Right.
Now, if you're Google and you have that amount of traffic, all right, 1% might be a few dollars.
That's right.
But for Sugar Learning or for most websites, you can bear that 1%.
And you could argue that that 1% increase in cost is way less than what you would have to spend on fixing whatever attack you might have to resolve due to you not having
Yeah,
HTTPS.
there's a good sort of
you know, you got to
ROI
make
there.
up the numbers, but
So there's that, and the other one, and this one is pretty much just about gone now, is it's dependencies on external services that might be HTTP only. So that the classic one was, look, I really want to use it, but my ad network only supports HTTP. Right. And if my page is HTTPS and I put something HTTP into the page, then I'm going to get a mixed content warning, and you get triangles and symbols and worrying things. But certainly the major ones now support HTTPS. And every now and then I see something really obscure where it's like, yeah, this site doesn't support HTTPS. But it's normally one of the other reasons. It shouldn't be a reason anymore.
Because as far as I'm aware, there's no reason not to use HTTPS for pretty much anything.
No. So it's pretty good. And to be honest, if I was starting a new site now, and this is what I did with things like this, is just start with HTTPS, like just from the outset.
Exactly.
It just makes it so much easier. Yep. All right, so there's one final thing on there which is just a little bit interesting, which is that and we just saw this, you don't have on your session ID a secure flag.
Yep.
Now, is this...
I did notice that before, and I was wondering when you would pick on it.
Is this by design?
I wouldn't have thought so. That's a good question. Now we're down into really nitty-gritty stuff, and I'm wavering. I don't think it is by design.
And this is an easy fix too, because it's just a web.config fix. Yep. So in ASP.NET, it's just it's literally like one attribute or one element in your configuration file to go, look, basically make it I think it's SSL only is the flag that you'll see.
Yeah, I have seen that.
So that one is a piece of cake to solve.
Excellent, very good.